So here's another question. Um, there are 8 red socks and 6 blue socks in a drawer. A sock is drawn, is taken out, it's color noted, and it is put back in the drawer. This procedure is performed 3 times. Let R be the random variable, the number of red socks taken. So determine the probability distribution of R and represent it in a table. So the key thing here that I just want to kind of highlight is this one here. So our focus here is that let R be the random variable, the number of red socks taken. So when we prepare our sample space, that is our focus. Anyway, let's carry on. So um, the selections here have been done 3 times. So probably a tree diagram will be the best way to represent our sample space. So we have the first selection. So we have red or blue, and this is the second selection. And then we have red and blue again, and then we have the third selection. Yeah, so third selection. So we have again red, okay. So we know that so not the probability of red picking a red socks is 8 out of 14, and probability of picking blue is 6 out of 14. Now, coming back here, we can determine the probability for each of these branches. Yeah. So this will be red, followed by red, followed by red. Let me just write this. So probability of red followed by red followed by red will be 64 out of 343. Yeah, if you simplify these fractions and then just multiply them out, probability of red followed by blue, that will be equal to 48 out of 343. It's kind of a tedious process. Red, blue, red, that will be equal to 48 out of 343. Then here we have red, blue, blue, which is 36 over 343. You have probability of blue, red, red, and that will be 48 over 343. Here we have probability of blue, red, blue, which is 36 over 343. Here we have probability of blue, blue, red, 36 over 343. And here we have probability of blue, 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 which is 27 over 343. So we can kind of come back here and try to, in preparation for plugging this stuff in a table, we can find the probability that of obtaining 0 red, because that is our random variable here. 0 red, that will mean we have blues, which will be 27 over 343. Probability of obtaining 1 red, that will be 36 plus 36 plus 36 over 343, and that simplifies to 108 over 343. Probability of obtaining 2 reds, that will be again 48 plus 48 plus 48 over 343, which will be equal to 144 over 343. And then probability of obtaining 3 reds is just 64 over 343. All right, so we kind of, put everything together. We are almost there. We just need to plug this in a table. So I'm going to prepare a table here, because one of the other questions is to represent this in a table and a bar chart. So we'll do the bar chart in a minute. So first of all, the table. So draw our table. So here we'll have R, probability R is equals to small r. Plug in the values that R can take. Hope this probability graph. So we have 0, 1, 2, and 3. That's enough. Make it a little bit smaller. All right, so we have 3 there. Now, we've calculated this probability. So this is 27 over 343. This is 108 over 343. That is 7. And then we have 144 over 343. And then we have 64 over 343. Okay, so obviously it may be difficult graphing these guys in a table. So what I'm going to do is to write this as decimals. So this is 0.08, approximately 0.31, 0.42, and 0.19, just so that I can be able to graph them easily here. So again, here we have R, and then here we have the probabilities. Yeah. So we have the probabilities. And now to graph this, we have 0 there. We can have a 1 there, 2 there, and then 3. And then on the y-axis, I'll use 0.1 here. So 0.2, 0.3, 0.4, 0.5. I think that's about it. Okay, so we just need to estimate here. So 0.08, it's probably somewhere around here. So 0.08. And then 1 goes to 0.3. So somewhere around here again. These are just estimates, yeah, for the bar chart. So we have that. And then 2 goes up to 0.42. So 0.42 is again somewhere around there. Again, these are just estimates. And then 3, 0.19, so that's somewhere around here. Oops, not just, yeah, close, but not, yeah, somewhere there. Oops, nope, not there. Missed that again. So somewhere here. Yeah, somewhere around there. Okay, so this is the bar chart that represents those probabilities.